and welcome. So today we're going to be talking about 6.2, which is transformations again, but this time instead of stretches, we are talking about shifts. So we have two goals. I can identify various parent functions and states shifts applied in a description, equation, or function notation. And the other goal is I can graph vertical and horizontal shifts when given a description, equation, or function notation. So essentially, when you're given a description, equation, or function notation, you should be able to identify parent functions and be able to state what's going on and graph it. Okay? So, just a reminder, vertical, that is the up and down. Alright, the horizontal is the left to right. Okay, so this first page, I have 4 graphs, right? And these graphs are different shifts that have been applied to parent functions. Alright, now the parent function on these first 2 graphs are both x squared, right? And that's going to be that blue dotted line. So that is just the parent function itself. Now we have 2 other functions, right? We have x squared plus 4, and we also have x plus 4 squared. Alright? So we have 2 different graphs. Now you'll notice that both of them have x's, both of them have plus 4's. Now the difference is where we see it. We'll see it on the left graph. We have this plus 4 to the right of that squared, right? And here we have the plus 4 like in parentheses with the squared around it. Alright, so let's look at what's going on with this one. So with the plus 4 outside of the square of the parentheses, you'll notice that we have the graph that's moved up 4 from the original parent function, right? It's gone by a distance of 4 upwards. Right, with the plus 4 inside that square, inside that parenthesis, we'll notice that it went to the left 4. Which is kind of unusual, right? Because normally if you think positive 4, you would almost expect it to move in the positive direction by 4, but this one moved to the left in the negative direction. Kind of interesting there. Alright, on the bottom graphs we have the similar situation. So we have a x squared is our parent function in that dotted blue. Alright, and here we have an x squared minus 3. Alright, so an x squared minus 3. Let me keep the colors the same, actually. So we have x squared minus 3, and then it's not x squared, square root of x minus 3. And that is going to be in that black line. You'll notice that this is moved down 3 down 3 from the parent graph. And then on the right side, you'll notice that we have an x minus 3 inside of the square root. And what happened there is the graph moved to the right 3. Alright, so these are pretty much all the different shifts that you're going to see. Alright, now how we know which one is which? Well, first off, from last time with stretches and compressions / shrinks, we said that whenever there is anything outside of the function, outside of the operation, we said that was vertical movement. So you'll notice both of these left graphs, the one in orange, we'll notice that the plus 4 and the minus 3, those are outside of the operation, right? You have the x squared, and then the plus 4 is on the outside, right? You have the square root of x, and the minus 3 is on the outside. And you'll notice that both of these are vertical movement, right? The first one, plus 4, we literally went up 4. We went in the positive direction by 4. Here, the minus 3, we went in the negative direction. We went down by 3. We did exactly what we saw in the equation. Now, when it came to the stuff with our left and right movement, we'll notice that both of these, the ones in yellow, the minus 3 and the plus 4, those are inside of the operation, which we said with stretches was the horizontal or the x movement, right? And we're doing the opposite of what we see, right? So if we have a plus 4, we went to the left 4. If we have a minus 3, we went to the right 3. Alright? So that is the basics of your stretches. So if you have vertical, you do exactly what you see, right? Horizontal, you do the opposite, right? We don't have to do the reciprocal here. It's only reciprocal when you are multiplying. Here, you just do the opposite of what you see. All right, so I'm going to refer to these as shifts, but you're often also going to see the word translation, right? It's literally just another word for shift. Okay, so you have your vertical translation or shift, right? And that is identified by the number that is being added or subtracted on the outside of the function. Right? Likewise, the horizontal translation or shift can be identified by the number that is, again, added or subtracted on the inside of the function. All right, so if it's on the inside of the function, we call that the horizontal shift, right? And likewise, if it's on the outside of the function, whoops, we use that different color of orange. The struggle is real. Okay, we use that different color of orange for the vertical shift. Okay, so remember, last time the stretches were a multiplication and division, right? Stretches and compressions, multiplication, division. And now the shifts are all adding and subtracting. Okay, and it really just depends where you have it in your equation is what determines what kind of shift you have. All right, so just like a notice of what we talked about, right? If you have, right, this x minus h, right, you do the opposite, or you have to use the opposite sign of whatever h is. So if we have like x minus 3, right, then you do plus 3 would be the translation. Okay, so that's what that's talking about. All right, so example 5, graph the function given the equation, function rule or verbal description. Then we are filling in all that information down below. All right, so the first one we have x plus 4 squared plus 3. I'd say excellent. Okay, well, first off, x comma y, remember this is our parabola, our quadratic parent function. So that would be negative 1, 1, 0, 0, 1, and 1. And then from there, we want to figure out what we have going. So I'd say, okay. So first off, we have this x plus 4 inside of the square. So that's going to be a horizontal shift, right? And then this is a plus 4. So the opposite of plus is minus. Minus is in the left direction. So our plus 4 will be shifting us to the left by 4. All right, and the vertical, we love the vertical, right? Anything on the outside of the function will be a vertical shift because it's adding, subtracting, right? Vertical shift, it says plus 3. We do exactly what it says. Plus 3 will be in the positive direction, in the upward direction, so we are going up by 3. Okay, we can just write our equation function notation while we're at it. Right? We are literally giving the equation. Remember, we see the symbol, we see that square, so that tells us it's the equation. Now, if we want to write the function notation, the operation, the square symbol, it goes out, and in its place, we have f. Alright, so we have f of x plus 4 plus 3. So literally the same thing, and just instead of the operation, we have that f of x notation. Alrighty, so let's finish up the graph. So first of all, we know we're going to the left 4 on our x's. Whoops. Left 4 is subtracting 4. On the y's, we're going up 3. Up 3 is positive, so we add 3. So 1 plus 3, 0 plus 3, 1 plus 3. Negative 4 minus 1, 0 minus 4, 1 minus 4. Okay, you take your two outermost columns, and then we plot the point. So we have negative 5, comma 4. Negative 4, comma 3. And negative 3, comma 3. Oh, golly. Hold on. Hold. I'm like, this doesn't look right. Hello. 1 plus 3 is 4. That's so awkward. It's fine. Okay, there we go. I'm like, it should be there. Alrighty. It's fine. Life's great. Alright, so then I say, great, x squared. Now, x squared, you gotta remember, is that the u or is that the v? It's the u-shaped one. So we have the common down, have a nice like bowl shape at the bottom, comes back up. Okay, congratulations, you graphed it. We filled in the information. We're done. Right, so then we keep going from there, and we say, excellent. So from here, we are doing the same thing where it's a great. We have an f of x minus 5 plus 1. That is the function notation. So we're just going to copy that down. X minus 5 plus 1. Now what parent function do we have? We have ourselves an absolute value of x. So if we want to write the equation right away, right, then we have y equals, or g of x equals, our absolute value of x minus 5 plus 1. Same thing. Right, so what description-wise, what would we have going on? Well, first off, we have stuff on the inside. It's adding, subtracting, so that is a horizontal shift. I'd say, great, we see a minus 5. With the x's, we do the opposite. So the opposite of subtraction is addition. So we are shifting to the right 5, right? Because positive in the x direction is to the right. And then we see this plus 1 on the outside. Plus on the outside is a vertical shift, right? And we literally do what we see. So plus in the y direction would be going up. So we have a vertical shift up 1. All right, so let's get our table going. So we have x comma y. Absolute value is negative 1, 1, 0 over 0, and 1, 1. Okay, so I look at this absolute gem and I'd say, great, we're going to the right 5 on our x's, so that's adding 5, and then adding 1 because we're going up on the y's. So 2, 1, and 2, and then we have 4, 5, and 6. Yes, 4, 5, and 6. Wanted to make sure I didn't accidentally add any of these wrong again. That would be awkward. So you take your two outermost columns. We have 4, 2. All right, we have 5, 1, and then 6, 2. All right, absolute value, remember, is the V shape. So we just have our graph looking like that, right? Technically, it keeps going. I just stopped at the edge there. Alrighty, so that would be the basics of graphing transformations with vertical and horizontal translations.